Okay, this podcast is going to focus in on balancing equations. It's a little different from the other ones because there really isn't a set of PowerPoint slides. I'm mainly just going to use this format to step you through the process of balancing equations. Okay, the first thing to realize is that we balance equations because in chemical reactions, mass is conserved. All right, so conservation of mass is why we balance equations. And basically what conservation of mass says with regard to a chemical reaction is that the number and type of atoms in our reactants is equal to the number and type of atoms in the products. All right. Now, two words that we've used, but let's just clarify for them. When we have a chemical equation, it is set up where we have our reactants on the left side, we have a yield sign in the middle, and then we have our products on the right side. Reactants being the things that we start with, and then the products being what we're left with after the chemical reaction takes place. And the chemical reaction is basically just a rearrangement of the atoms. And so that's why we get conservation of mass, because we're not creating or destroying anything. We're just rearranging atoms in a chemical reaction. And so the number and types of atoms that we start with has to be equal to the number and types of atoms that we end up with. And in order to show that in a chemical equation, we do what we call balance it. So what I'm going to do is there is, next to the link for this podcast, there is a balancing equations worksheet. And I'm going to be using some of the examples off of there. So if you wanted to print that out before you look at this, or you can look at this and then go to the worksheet later. But that's where these problems are coming from on there. Okay, so we're going to start out with the first one on the balancing equations worksheet. And we have silver oxide, and it is breaking apart into silver and oxygen. Okay, I'm going to start out basically using what I call a bookkeeping approach, and where we're going to basically look at the atoms that I have on the reactant side. That's silver and oxygen on the product side. On the reactant side, I have 2 silvers and I have 1 oxygen. Product side, I have 1 silver and 2 oxygens. The key thing to remember here is I already have my balanced formulas written out here. I can't change subscripts when I'm balancing an equation, because if I change a subscript, I'm actually changing what the substance is. So the only thing I can do is I can put numbers out in front of the formula for the compound or the element, and that will multiply through everything that's in the substance, but it won't change the formula. It won't change what the substance is. Okay? Whoops. I didn't mean to do that. Let's do well, I thought I could change the color. There we go. Yeah, let's do some blue. Okay, so typically the process, a good process to follow, or the order in which you are to balance that will help you out, is first balance the metals. Second, balance your nonmetals. And third, well, go back up here, except the nonmetals except for oxygen and hydrogen. You want to balance oxygen and hydrogen last. Okay, and then you're going to be rebalancing as needed. Alright, so let's go through these steps using our bookkeeping method here. Eventually, you should be able to wean yourself off of using the bookkeeping method, but this way kind of helps you get the whole point of what we're doing. Alright, so metals first. Silver. I have 2 silvers on my reactant side, 1. Only thing I can do is make one of them bigger, so I'm going to put a 2 in front of the silver on the product side. That changes this to 2. Okay, so now I'm balanced on my silver, so let's go to the oxygen. I have 2 on the product side, 1 on the reactant side. So I'm going to put a 2 in front of there. So I now have 2 oxygens, but I've also now changed my silver. So I have 2 times 2, or 4 silvers. Okay, so now this is where we have to rebalance. I'm going to go back, and so now instead of a 2 over here, I'm going to make this a 4, which means I now have 4 here, and now they match. 4 silvers, 4 silvers. 2 oxygens, 2 oxygens, so now this is balanced. Okay? Alright, so let's look at another example. Let's look at problem, how about number 4? In a combustion reaction, we have octane and oxygen. It's going to give us CO2 and water. Okay? Now, alright, let's do our little accounting thing. I have carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Okay, I've got 8, 18, and 2. Here I have 1. I have 2 hydrogens. In the oxygen, I have 2 in the carbon dioxide plus 1 from the water. So I have 3 oxygens. Okay, so we're going to do the carbon first. I have 8 here, 1 there. Oops, let me switch my ink colors so you can see this again. We'll go back to red. Okay, so I'm going to put an 8 there, which is going to give me 8 carbons, and then it's also going to change my oxygen. So I have 8 times 2 is 16, plus the 1 from the water will give me now 17 oxygens on that side. Alright, so let's go, we'll go to our hydrogen next. Okay, I have 18 here, I have 2 on my product side, so I'm going to put a 9 in front of the water. That is going to give me my 18, but now I've changed the oxygen again. So I have 8 times 2, so 16 from the carbon dioxide plus 9 from the oxygen, and that's going to give me 25, okay, oxygens on the product side. Alright, so now we have an issue that comes up quite often where I have an odd number of oxygens on my product side, but because it's O2 on the reactant side, this is going to give me only an even number. When this happens, what you're going to do is go to whatever it is that's making the oxygen, in this case, odd, and double it to make it even. So I'm going to go over here, and it's that 9 right there on the water that's giving me an odd number of oxygen. So I'm going to double this and make it 18. Okay, now that's going to adjust. I'm now going to have 36 hydrogens, all right, because I changed that, and I've got 8 times 2, well, yeah, 36 hydrogens, and I'm going to wait to count the oxygens again because I know I'm going to have to change this hydrogen. So I'm going to put a 2 in front of that. That's going to give me 36 there. I'm going to have 16 carbons now because of that. Now let's go back over here. I've got 8 here, but I need to change that now to 16. So now my carbons are 16, my hydrogens are 36. The oxygen, I've got 16 times 2, so that's 32 oxygens from the carbon dioxide, plus 18 from the water, so that's going to be 50 oxygens. Now I've got an even number on my oxygen, so I can come back over here, and if I put a 25 coefficient on the oxygen, that's going to give me 50, and it's only changing the oxygen, so now it matches, and I am balanced. Okay, alright, let's look at another one. How about number 14? Okay, I have a barium carbonate plus carbon plus H2O. Oops, I didn't leave a lot of room for my coefficients there. Yield carbon monoxide and barium hydroxide. Okay, alright, while I'm doing this, let me move our little plus sign out of the way so I can go back and put it there. I have a little more room that way. Okay, change my ink color. Alright, so now I have barium, carbon, oxygen, hydrogen. Barium, carbon, oxygen, hydrogen. Okay, so I have 1 barium, I have 2 carbons, 3 plus 1, so I have 4 oxygens, and 2 hydrogens. Okay, over here I have 1 barium, I have 1 carbon, 1 plus 2, so 3 oxygens, and 2 hydrogens. Alright, my barium looks good. So there's my metal. Non-metals, carbon, I have 2 here, I have 1 here. So I'm going to put a 2 there, make that a 2. And now my oxygens on this side are 2 plus 2, so I now have 4 oxygens. Alright, so that's matched up. Oh, and that did it. Okay, so that one was easy. Just needed that one coefficient, and that one is balanced. And sometimes they'll work out that way. Let's do one more, and then what you can do is pull up this balancing equations worksheet. The answers are in the file as well, so you can kind of check yourself as you go. All right, so let's look at, how about number 12? Right, so we have PbNO3, lead nitrate, lead 2 nitrate actually, decomposing into lead oxide plus nitrogen dioxide plus oxygen. Okay. Again, I have lead, nitrogen, oxygen are my elements. Okay, and we'll change our pen color. Okay, on this side I have 1 lead, I have 2 nitrogens and 6 oxygens. I have 1 lead, 1 nitrogen, and 1, 2, 3, 4, 5 oxygens all together there. Okay, my lead is okay. Nitrogen, I have a 2, so I'm going to put a 2 here. So that gives me now 2 nitrogens, and I have 4, 5, 6, now I have 7 oxygens. Okay, let's see what we're going to do with this one. Alright, we got an odd over here. This one can only be even. So we're going to follow our little rule where I'm going to look to see on this side, that oxygen in the lead oxide is what's making it odd. So I'm going to put a 2 right there. Alright, so that's going to give me now 2 leads. That's going to give me 2 plus 4 is 6, 7, 8. That's going to be 8 oxygens. And the nitrogen is still the same. So now my lead, I need to rebalance. I'm going to put a 2. So that's going to give me now 2 leads. I'm going to have 2 times 2, so that's going to give me 4 nitrogens. And 2 times 6 is going to give me 12 oxygens. So now let's fix the nitrogen. Change that to a 4. Makes that okay. And my total oxygens now, I have 2. 4 times 2 is 8, so that's 10. Plus 2 is 12. And we are balanced. Okay. That's pretty much balancing equations. If you have any questions about that, just ask me in class or just do some practice and make yourself really good at it and really fast at it. And I will see you guys tomorrow.